Hello everyone, welcome to this video lesson. In this video lesson, we are talking about a chapter called ray optics. Within the chapter, we are in a subtopic called something like reflection of the light by a plane surface or a plane mirror. The problem that we are handling here is like this. We need to calculate the minimum height of a plane mirror required for a man to see his complete height. He shall be able to see his complete height. What is the minimum height required? Height of the mirror required is the question, right? Assume this is the head of that man, this is the feet of the man, this is the man who want to see himself in a mirror. Before him there is a mirror, plane mirror. We want to know what shall be the height of this mirror. Say for example, I can name this something like dash or height, whatever it is, so that he can see himself completely. Assume like the person is having an eye here. It doesn't make a difference where it is, just for the sake of observation. So what has to happen if he has to see himself is simply light ray has to fall from the head part. Assuming there is a kind of a source behind it, and falls on one edge of the mirror. It can fall within the mirror part also, need not be on the edge. Anyway, as we are calculating the minimum height of the mirror, let us assume that from head it is falling on one end of the mirror, and then it reflects back towards the eye like this. From the another part, that's the feet part, again light is falling and striking the other end of the mirror. It is getting reflected back towards the eye. That's how for the person or for the eye, the light rays appears like coming from a particular point. Where it is, what is this light ray I will do is actually extend this light rays, and the eye sees the image behind the mirror, which is called something like a virtual image. This is where image of head of the image, this is nothing but feet of the image. We want to know if this has to happen, what shall be the dash value. But one point probably you need to understand is, being the mirror is a plane mirror, if the object is at a distance x, that means if the person is standing before the mirror at a distance x, behind the mirror the virtual image of that object is formed at the same distance x. Now you can see there is a kind of a similar triangle. If I name this point as something like OM dash, and triangle OH dash F dash. This is one triangle OM dash OH dash. This is one more triangle OH dash F dash. One more triangle. These two triangles are obviously similar triangles because they are sharing the common angle theta. So I would like to say are similar triangles. As the triangles are similar, the ratios of the sides must be the same. So the opposite side of the first triangle is dash, and the opposite side of the second triangle is h dash f dash, which is of course equal to the size of the man itself, because being a plane mirror, its magnification is 1. That means object size and image size are equal to, say, I can write now this distance. For the triangle OM dash, the distance is nothing but equal to x. For the triangle OH dash F dash, the same distance is this total value. This is x, this is another x, because that's the distance of the image from the object. So the total distance is nothing but equal to 2x. X and x gets cancels. So dash is nothing but size of mirror. H dash F dash is nothing but height of man, 1 by 2. That implies the size of the mirror required so the man completely is height of man by 2. So if you want to see yourself completely in a plane mirror, you shall have a mirror whose height is at least half of your height. It is obviously independent of where you are standing before the mirror. So I would like to say this is independent of where you are standing. Of course, you are at a limited closer distance to that of an image from mirror. Thank you for watching. Keep coming back for more and more video lessons. Thank you.